Welcome back to science class. My name is Miss Rillieux, and today we will be discussing counting atoms. Before we begin our discussion on counting atoms, we will first review our lesson from last week on cell organelles. Last week, we discussed the 7 cell organelles and their structure and function. For today's warm-up, we are going to match the name of the organelle to its correct function. Let's begin. The name of the first organelle is mitochondria. Can anyone find the function of the mitochondria? Is the mitochondria where photosynthesis takes place, allows materials in and out, protects and supports the cell, gives the cell energy, is the gel-like substance, or controls the cell? Which of these is the correct function of the mitochondria? Yes, the function of the mitochondria gives the cell energy. It is the powerhouse of the cell. Let's go to the next one, the nucleus. Is the function of the nucleus where photosynthesis takes place, allows materials in and out, protects and supports the cell, is the gel-like substance, or controls the cell and contains DNA? Yes, the nucleus controls the cell and contains DNA. Cell membrane. What is the correct function of the cell membrane? Is it where photosynthesis takes place, allows materials in and out, protects and supports the cell, or is it the gel-like substance? Yes, the cell membrane allows materials in and out. Let's go to the other side, cell wall. Is the function of the cell wall where photosynthesis takes place, protects and supports the cell, or is it the gel-like substance that holds the cell organelles in place? Yes, the cell wall protects and supports the cell. Cytoplasm. Is the correct function of cytoplasm where photosynthesis takes place, or the gel-like where photosynthesis takes place, or the gel-like substance that holds the cell organelles in place? Yes, the cytoplasm is the gel-like substance that holds the cell organelles in place. Last one, the chloroplast is where photosynthesis takes place. So let's review. The mitochondria gives the cell energy and is the powerhouse of the cell. The nucleus controls the cell and contains DNA. The cell membrane allows materials in and out of the cell. The cell wall protects and supports the cell. The cytoplasm is the gel-like substance that holds the cell organelles in place. And the chloroplast is where photosynthesis takes place. Now that we have reviewed what we did last week, let's discuss this week's objective. This week, we will be discussing 8.5D. Recognize that chemical formulas are used to identify substances and determine the number of atoms of each element in chemical formulas containing subscripts. The agenda for today. First, we are going to discuss the rules for counting atoms. We're then going to practice counting atoms within compounds. Next, we will play the counting atoms game. And last but not least, we will complete an exit ticket containing STAR practice questions. The materials you will need today include paper and pencil. The rules for counting atoms. Get your paper, get your pencil, and the first thing we need to discuss are subscripts. Subscripts are only referred to the atom that they are behind. This little 2 is a subscript. It is behind the symbol H, which represents the element hydrogen. There are 2 atoms of hydrogen in this compound. There is only 1 atom of sulfur. How do we know that there is 1 atom of sulfur? Sulfur does not have a subscript behind it. When an element does not have a subscript behind it, that means that that element only has 1 atom. Unlike hydrogen that does have a subscript behind it, which is the reason why hydrogen has 2 atoms. One more time, in this compound, hydrogen, there are 2 atoms. Sulfur, there is 1 atom because the subscript is not there. Again, if the subscript is not there, then there is only 1 atom of that element. The second rule is about coefficients. Coefficients apply to the entire compound. That means in this compound, the coefficient is the large number 2, and it will be applied to the H and applied to the S. You multiply coefficients, the big number, and subscripts, the small number. For example, in this compound, there are 4 total atoms of hydrogen because we multiplied the coefficient of 2 times the subscript of 2 to give us 4 atoms of hydrogen. In this compound, there are only 2 atoms of sulfur. To get 2 atoms of sulfur, we multiply the coefficient of 2, the big 2, times the imaginary 1. Remember, when an element does not have a subscript, that means that element only has 1 atom. So because sulfur does not have a subscript, we know that there is an imaginary 1 here. So we multiply our imaginary 1 times our coefficient, the big number 2, to give us a total of 2 sulfur atoms. Again, if there isn't a subscript behind an element, assume there is only 1 atom of that element. I'm going to give you a couple seconds to write down your definition for coefficient. Again, the coefficient is the big number, and it must be applied to all of the elements within the compound. So this coefficient goes to hydrogen. This coefficient also goes to sulfur. About 20 seconds to write down what a coefficient is. You have about 10 seconds left. All right, let's move on to the third rule in counting atoms. Parentheses. If elements or compounds are inside of parentheses, then the subscript behind the parentheses applies to everything inside. For example, O and H, oxygen and hydrogen, are inside of the parentheses. So the subscript outside of the parentheses applies to both hydrogen and oxygen only. The subscript outside of the parentheses does not apply to BA because BA is not in the parentheses. I'm going to say that one more time. The subscript of 2 applies only to the elements inside of the parentheses, which are O, which represents oxygen, and H, which represents hydrogen. This compound contains one atom of BA because BA does not have a subscript behind it. Whenever an element like BA does not have a subscript behind it, we assume there is an imaginary 1, which is why BA has one atom. Oxygen. Oxygen does not have a subscript behind it, so we assume there is an imaginary 1. H also does not have a subscript behind it. So again, we assume that it is imaginary 1 behind H. So O has an imaginary 1, H has an imaginary 1. We need to multiply O's imaginary 1 by the subscript outside the parentheses, which is 2. And we need to multiply H's imaginary 1 by the subscript outside the parentheses, which is 2. So O1 times 2 gives me 2 atoms of oxygen, and H1 times 2 gives me 2 atoms of hydrogen. Again, the way that we calculated 2 atoms of oxygen and 2 atoms of hydrogen is by multiplying the imaginary 1 next to oxygen by the subscript outside of the parentheses. Imaginary 1 times 2 gives me 2. Same thing with hydrogen. Imaginary 1 times the subscript 2 gives me 2. Let's practice. So let's first practice rule number 1, subscripts. Let's look at our compound, Mg. Does Mg have a subscript behind it? No, Mg does not have a subscript behind it. Therefore, we know that there are 1 atom of Mg because there isn't a subscript behind it. Let's look at Cl. Cl has a subscript behind it. So because Cl has a subscript behind it, how many atoms of Cl are in this? How many atoms of Cl are in this compound? Yes, 2. So now for the next 30 seconds, I want you to tell me how many of atoms of aluminum are in this compound and how many atoms of sulfur are in this compound. So 30 seconds starting now. You have about 15 seconds left. Remember to look at your subscripts, which are the small numbers. All right, so how many atoms of aluminum are in this compound? Aluminum has a subscript of 2, so we know that there are 2 atoms of aluminum. Sulfur has a subscript of 3, so we know that there are 3 atoms of sulfur. Let's try one more. So H, subscript 2, S, and O. I'm going to give you 20 seconds, and I want you to tell me the number of atoms of hydrogen, number of atoms of sulfur, and then the number of atoms of oxygen. 20 seconds starting now. You have about 10 seconds left. Remember to look at your subscripts. And remember what to do when an element does not have a subscript. So let's start with H. Does H have a subscript? Yes, H has a subscript. Therefore, we know that there are 2 atoms of H. Does S have a subscript? No. S does not have a subscript, therefore we know that there are only 1 atom of S. Does O have a subscript? Yes, O has a subscript, therefore we know that there are 4 atoms of oxygen. Let's practice rule number 2. So rule number 2 and 3. Let's practice rule number 3 with parentheses. So we're going to do the first one together. Ca is not in the parentheses, so we don't have to do anything special. We can do exactly what we did previously. Ca has a subscript. So how many atoms of Ca are there? Yes, 3. Now, P and O are inside of the parentheses. So that means that P and O, they both must be multiplied by the number outside of the parentheses. So let's start with P. Does P have a subscript next to it? No. P does not have a subscript behind it. Because of that, we know that it has an imaginary 1. So we multiply the imaginary 1 times the number outside the parentheses, which is 2. So 1 times 2 gives us 2. Let's look at O. Does O have a subscript behind it? Yes, O has a subscript behind it, which is 4. So we multiply 4 times the subscript outside the parentheses, which is 2. So 4 times 2 gives us 8. For the next 30 seconds, I want you to tell me the number of atoms of aluminum, number of atoms of sulfur, and then the number of atoms of oxygen. 30 seconds starting now. Again, look at your subscripts. Remember what to do when an element does not have a subscript. And remember to multiply the number outside of the parentheses by everything inside of the parentheses only. You have about 10 seconds left. So let's look at aluminum. Does aluminum have a subscript behind it? Yes, aluminum has a subscript behind it. Therefore, we know that there are 2 atoms of aluminum. Let's look at sulfur. Does sulfur have a subscript behind it? No, sulfur does not have a subscript behind it. Therefore, we assume that there is a 1, and we multiply sulfur's 1 by the number outside of the parentheses, which is 3. So 3 times 1 gives me 3 atoms of sulfur. And let's look at oxygen. Does oxygen, O, have a subscript behind it? Yes, it is 4. So we multiply the 4 times the subscript outside of the parentheses, which is 3. So 4 times 3 gives us 12 atoms of oxygen. We're going to go into our game for today. And we're going to practice what we learned during our introduction and guided practice. How many atoms of oxygen are in this compound? 10 seconds. Yes, there is only 1 atom of oxygen. How many elements are present in this compound? So elements, remember, are what we discussed a couple weeks ago. They can be found on the periodic table. Or you can just count the capital letters. So how many capital letters do you see in this compound? 1, M, A, C, O, H, and N. So 4, 6. Last one. How many atoms are in the element carbon in this compound? How many atoms of the element carbon are in this compound? First, we need to find carbon. Carbon is represented by what letter? C. And does carbon have a subscript behind it? Yes. So how many atoms of carbon are there? Right, there are 3. All right, great job. So let's end today's session with some practice star questions. Serotonin is a chemical substance that acts as a neurotransmitter. It helps relay messages in the human brain. The formula for 1 molecule of serotonin is shown below. The question is how many atoms in all are in a molecule of serotonin? So the key here is all. Just like that last question, if they want all, do we need to add or subtract? Right, we need to add because it says all. So let's get started. How many atoms of carbon? You need to ask yourself, does carbon have a subscript behind it? Yes, it does. So that means there are 10 atoms of carbon. Does H have a subscript behind it? Yes. So you need to add 10 plus 12. Let's keep going. Does N have a subscript behind it? Yes. So now we need to add 10 plus 12 plus 2. And let's do the last one, oxygen. Does oxygen have a subscript behind it? No. So we need to assume that it only has one atom. So to get the answer, we add up the number of atoms for carbon, hydrogen, nitrogen, and 1 for oxygen. So what would be our total for this compound? Ten seconds. Our total would be 25. 10 plus 12 plus 2 plus 1. Last question. The chemical formula for sodium sulfate is Na2SO4. How many sulfur atoms are in the formula for sodium sulfate? A1, B2, C6, D7. I'm going to give you about 20 seconds. You have about 10 seconds left. The key is how many atoms of sulfur. First, what is the symbol for sulfur? Is it Na, S, or O? The symbol for sulfur is S. Does sulfur have a subscript behind it? No, sulfur does not have a subscript behind it. Therefore, we know in this compound there are only one atom of sulfur. There is only one atom of sulfur, so the answer is A. That is everything that I have for you today. Thank you for joining me. And again, see you next week. Bye-bye.